This afternoon we're talking about reaction of alkene. And what is alkyne itself? Alkyne is an unsaturated hydrocarbon with carbon-carbon triple bond. So we have it like this. And don't forget that the first member of alkyne is ethyne. So now we're picking ethyne as a case study for this reaction of alkyne. So the first reaction here, we call it combustion. The second one is hydrogenation. The third one is halogenation. The fourth one is halogenation. The 15th one is with water. 6 with potassium permanganate. So I'm going to talk about these 6 under the reaction of alkyne. So let's pick the first one. Don't forget, anything by combustion, it means that they involve ethyne with air. You know, combustion mostly deals with what? Air. So now let's say we have ethyne react with air, which is this, to form carbon dioxide and water. And don't forget that oxygen undergoes complete combustion, and when they do so, they produce what we call a brilliant flame and not smoky. And don't forget that the flame is about 3000 degrees Celsius. So now let's pick up ethyne, which is what? The first member of ethyne, which is C2H2 plus the oxygen gas. We have this. And the oxygen gas or oxygen molecule is the air. So it's this. I have carbon dioxide because we are meant to know that if they react together, they'll give us carbon dioxide and water. So with that, I can have my 2 here, I have my 4 here, I have my 2 here, I also have my water here, 5. And how do we have this number? If you don't mind, under the balancing of chemical equation, we have one rule that said what? We can use try and error method. If you try one number, if it does not work, you try what? Another number. So this is what? Ethyne. Here we have air. They produce the carbon dioxide and water. So that is for the combustion of alkyne. The second one is hydrogenation. The second one is hydrogenation. And when talking about this hydrogenation, ethyne reacts with hydrogen molecule in a finely or produced by divided Nickel catalyst at about 200 degrees Celsius to form ethane. So let's check this out. Ethane, don't forget, is C2H2 plus hydrogen molecule. The product, we don't know it. And how does it produce ethane? Don't forget, the catalyst is what? A car at 2 degrees Celsius. So now we have 2 of hydrogen atom now. When reacts with this, we are going to have what? The next product. So let's show the structural formula of that. I have triple bond, 1 hydrogen atom, the second one, plus the 4 hydrogen. 2 times 2 give us what? 4. So with that now, I can say that 1 hydrogen here, second one, third one, and what? The fourth one. One of these will come to this place to break this bond. This will come to this place to break this bond. So with that, the other 2 here fill this vacant space. While is also what? Fill this vacant space. So with that, I can say that I have this, and this is called ethane. So when ethane reacts with hydrogen halide, they produce what we mean by what? Ethane. So the third one is halogenation. And when talking about the halogenation of alkene, don't forget the word halogen. It means they can react with any halogen, and those halogen that they can react with can be iodine, bromine, or chlorine. So ethane reacts with chlorine and bromine in the presence of metallic chloride at room temperature to produce halogenated compound. Can you see it now? So let's show that. And when they produce halogenated compound, we can have 1,2-chloroethene, 1,2,2-dichloroethane. So now let's take the first one. We have C2H2 plus chlorine gas. So I can just say like, because we're adding 2 of this chlorine to this, and with that I don't know the product. So let's show the structural formula of that. I have this triple bond, 1 hydrogen, the second one. So now plus 2 chlorine. So one of this here will move here, one of this here will move here. So break this bond and turn it to what? A double bond. So with that I can have this double bond, 1 chlorine, second chlorine, and I have what? Hydrogen. Don't forget the chain will continue until we have ethane, which is an addition reaction. So I have this also now. So I call this 1,2-dichloroethene. So now what will be the next product? Mind we have 2 chlorine here. So one of the first one will come here to break this double bond to turn it to what? A single bond. So with that I have chlorine, 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 the hydrogen here, the hydrogen here. So what this one is named 1,1,2-tetrachloroethane, because we're having the parent continuous carbonation to be ethane. So let's take the first one, which is hydrohalogenation. And what do we mean by that hydrohalogenation? It's very simple. So when we're talking about this hydrohalogenation, it means that ethane reacts completely with hydrogen halide to form 1,1-diiodoethane. So let's take that. Ethane is C2H2 plus the hydrogen halide. We don't know the product. So it's this triple bond. So I have the halogen and the hydrogen. One of it will come here to break the bond. This one will also what? Come here to break the bond. So we are going to have a double bond. 1 hydrogen, the hydrogen, and we have what? The hydrogen. So how do we have 1,1-diiodoethane? So it's that. Now I can call this one vinyl iodide, or I call it iodoethane. So I will call it iodoethane. We call it 1-iodoethane. So let's complete the what? The mechanism now. Don't forget we are using hydrogen halide. So one of this here will come here, and this hydrogen will come here to break this one and turn it to what? A single bond. So with that we have this iodine. I have iodine. I have what? Hydrogen atom, which is this. So with that 1,1-diiodoethane. That is for the hydrohalogenation. So the fifth one is with water. How does ethane react with water? And take note of one thing. So I call it with water. So when ethane reacts with water at about 960 degrees Celsius in the presence of sulfuric acid and mercury sulfate. They yield ethanol. So let's check that. What is our ethane? And don't forget I said that ethane will react with water at about this degrees Celsius at room temperature. In the presence of sulfuric acid and mercury sulfate, they yield what we call ethanol. So let's show that. So I have C2H2 plus H2O. So now, how does this have or how does it produce what? Ethanol in the presence of sulfuric acid or silver sulfate as the catalyst. So now, we have triple bond for this. Don't mind we have what? Plus H2O. And don't forget that the sulfuric acid and the mercury sulfate are our initial catalyst. Now, if I'm to open this water, I have hydrogen ion plus hydroxy ion. With that, this reacts with this. This reacts with what? This. So I'm going to have H, and when they are reacting, they are going to break this bond here, turn it to what? A double bond. So I have one hydrogen atom here, the carbon here, one hydrogen atom here, OH, which is this. I said it now. So the next thing is we have to rearrange. So don't forget our main target is that when these two react with this, in the presence of these two here, which is the catalyst, they are going to give us ethanol. So it's that. I have this. Mind you, this hydrogen atom here, we come to this particular place. And this double bond here will shift. So it's that. I have. So this one here will move here. So we have this to the double bond. And I have the hydrogen atom here. So I can call this what? Ethanol. So the last one, which is with potassium permanganate. Take note about the reaction of alkyne that under the potassium permanganate, I can say potassium permanganate is a good reducing agent as a chemist. And don't forget that when this reacts with ethane, they decolorize or acidify to produce what we call by ethane 1,2-dioic. So it's that I have C2H2, which is the ethane, plus 4 oxygen atom from this potassium permanganate as the catalyst. So now let's show the structural formula of this. I have this triple bond. I have one hydrogen here, what? One hydrogen here. Plus 4 oxygen atom. Mind you, if this 4 is coming here, 2 will attach itself to this. The other 2 will attach itself to this. To break this bond and turn it to what? A single bond. And with that, I'm going to produce what we call by oic. So, we have COOH. So I call this 1,2, or say ethane 1,2-dioic acid. And take note of one thing. Anytime or ethane reacts with potassium heptaoxodichromate, it changed the green color. Sorry, it changed the orange color to green. So thanks for watching. Don't forget to subscribe.